Hello and welcome everyone. Good morning, noon, or evening, depending on where you are joining us from. I am Dr. Bushra Anjum, and I am the host for ACMW Celebrating Technology Leaders series. This series is designed to demystify various career options. In each of these episodes, we invite women leaders who are successfully architecting their careers in a particular field under the general umbrella of computing. Today, we are focusing on careers in robotics, and we have a wonderful panel arranged for you. A few logistical points. I will be facilitating the discussion for the first 45 to 50 minutes, and the final 10 to 15 minutes are for you to ask any questions to our panelists. Please feel free to write in and send your questions throughout the discussion. You will find a Q&A window on your screen. You can just type in your question there and hit submit. Also, on the bottom panel, you will find a number of widgets, including Twitter and sharing apps. We encourage you to share any nuggets that you may find useful in this discussion, as surely it will help others in your network too. Thank you for spending the next hour with us here today, and we will make every effort to make it worth your while. So let's start. 100 years ago, a play premiered in what is now called the Czech Republic that introduced a significant new word to the world, robot. In the play, there were artificial biological beings that resembled humans. That play got a lot of people thinking, and it also shaped people's perceptions of what a robot is and what the potential dangers they pose. 100 years later, we have a great panel to take on that discussion forward. We have with us Laura Stelzner. She has a MS in Computer Science from Stanford and currently serving as a Principal Robotics Software Engineer at RIOS Corporation. Then we also have Dr. Sarah Gibson. She has a PhD in Electrical Engineering from UCLA, and she's currently working as a Senior Engineering Manager in Robotics at Unity Technologies. Our third panelist was not able to join us today because of last-minute work commitments. So let's begin the discussion. How did your unique personal background and interests and career aspirations lead you to where you are today? Laura?
So when I was applying to undergrad back then, I didn't really know what I wanted to do. I had enjoyed my calculus class in high school, and I had always enjoyed computers, and my dad was a mechanical engineer. So I kind of, as I was applying, decided I'll do computer engineering because that sounds interesting to me, but I didn't really know too much what was involved in it. And so I attended UC Santa Cruz, and I was able to join them for a summer program they had called Engineering Summer Bridge, which collected students from underrepresented backgrounds that were interested in studying engineering and technology. So they gave us kind of like some basic overviews, some very simple programming classes, as well as introduced us to different resources that were available on campus to kind of give us a head start to make certain that we would stick with the program. And it was a great opportunity to get to know other students. So when you started your first classes, you had some peers with you. And so as I went through my coursework at Santa Cruz, I really enjoyed all the engineering coursework. I took a mechatronics class in my junior year, and this is basically a robotics class. It was very project-based. You had a team of 3 people. You were designing a robot more or less from scratch. You had to do the mechanical design, the electrical design, as well as the software. So that's really what piqued my interest in robotics, was the integration of all those pieces together and getting to see the robot work in the real world. While I was there, I was involved with Society of Women Engineers, and I posted my resume on their database. So when I graduated, I actually got contacted because I had my resume up there, and that led to my first job, which was at Raytheon, which is a defense contractor. I was doing embedded software as well as some higher level signal processing software there. And so when I graduated, I kind of had the idea that I wanted to work for a couple years and then get my master's. And so after about 3 years, I decided it was a good time, that if I was going to go back to school, then was the time. So I applied a couple places with the intention of focusing in robotics to make myself more hireable in the industry. And so I attended Stanford. I got accepted into their computer science master's program. I decided to focus on artificial intelligence because that incorporated a lot of the robotics coursework. And as I was finishing up was when Google went on its robotics company buying spree. So there wasn't as many companies or jobs that were hiring in robotics at that time. So I went and worked at Space Systems L'Oreal, designing software systems to test satellite components. And so after about a year of that, I decided that I wanted something different. I found an engineering firm that was building robots for a customer, joined them, worked on building robot prototypes and programming them in RIOS for about 1.5 years. At that point, their customer decided to not renew the contract. From there, I moved on to Toyota Research Institute, where I worked on the home robotics and the shared autonomy teams. And again, I was using a robot operating system, ROS programming, doing all sorts of portions of the robot software stack. And after almost 3 years there, I decided I kind of wanted to try a early stage startup. And so I joined RIOS, and we work on artificial intelligent robots for factory automation type tasks. And it's been really interesting and fun thus far.
Go ahead, Laura. Excuse me, go ahead, Sarah.
Okay, so I, similar to Laura, also didn't really know what I wanted to do when I was in college. I was also attracted to math and physics, so I became an engineering major. And about the time when I was graduating, the only thing that I really knew was that I wanted to keep learning because I loved school. And I had a couple of summer internships during my undergrad in academia, research type environments. And so I decided to go to grad school without really having a plan of what my end goal was. I just wanted to keep learning. And so I got a PhD in electrical engineering with a focus on signal processing. And then from there, my first job out of school was at Qualcomm Research. And this was in 2012. So it was right about the time when neural networks were peaking again, like they were winning the ImageNet competitions. And so like everyone was turning their focus to AI and machine learning. And I first joined a team that was working on spiking neural networks, which was a really interesting project. But from there, I sort of transitioned into learning about studying reinforcement learning and how that can be used to train control systems. And so from there, we pivoted our project to a robotics project. And I joined a team called the Snapdragon Flight team, which was developing a product, a board for robotics specifically, that uses a Snapdragon processor, which is the same processor used in mobile phones, but the board was designed for robotics. And so I was working on the autonomy team, where we were using also ROS to program drones to do autonomous visual navigation. And so I worked on a really multidisciplinary team there, where we had mechanical engineers designing the custom drones. We had electrical engineers doing the board layout, and we had a software team doing a custom OS for this. We had a machine vision team. We had a flight control team. And so I was kind of like working on the top of the stack. And that was really my first exposure to robotics. It was a really good learning experience. I learned, what the latest research was in robotics, and also learning all of these open source tools like ROS was really great. From there, I moved to Microsoft to join a product team. So at Qualcomm Research, I was more on the research side, and I wanted to get experience in shipping a product. And so there I was working on a computer vision based product, and that's also where I first became a manager. And now I am at Unity Technologies where we're working on extending the Unity game engine to make it more easy to use in robotics simulations. And I've been there for about 6 months. It's really fun and exciting.
Thank you both for sharing your stories. And what I really like about our current panel is that you bring in perspectives both from the research side and very practical side of robotics. So I think that will become my first question. As I said in the introduction, the term robot has been here for about 100 years, and people have different ideas of what a robot is, and much of that is influenced by Terminator and other movies that we might have seen, or Westworld. But in the circles that actually work on robotics, whether it's practical or research, how is a robot defined? What is the understanding that, okay, if these are the characteristics present, then that's a robot? And the second part of the question would be, in the last 100 years, if you would like to point out a couple of really significant advancements that have happened in the field. Either of you want to go first?
I can take a stab at it. So the way that I would define a robot is, to me, an important aspect of it is that, so it's a machine, but an important aspect is that it's embodied and it's interacting physically with the world. So just like a computer, I would not classify it as a robot, even though it's doing intelligent tasks. So to me, a robot is something where you design it and build it to do a task. And usually it is sensing the environment around it, processing that data, doing computations, and then taking action in the world, which is usually involving moving physically, spatially. So that is how I would define a robot. The moving part is important. And in that, the moving part also introduces a lot of complexities and challenges. So as far as advancements, I think you can look at advancements in a couple of ways. For one thing, there's certain technological advancements that have really accelerated the field of robotics over the last 100 years. That's a long time window to look at. We have the invention of the digital computer, for example. And with Moore's law, the processors are getting smaller and more powerful over every couple of years, at least for the previous several decades. And so computers have been miniaturized and they're more portable. We have embedded systems, like even cell phones are basically a computer in your pocket. And this means that robots can physically carry more computation, more compute, and become more intelligent, have more on-device processing. We also have connectivity, like everything from Wi-Fi and Bluetooth to CDMA and 3G, 4G, 5G, which allows you to spread out computation across robots, or have like a spread between on-device and cloud computing. I think open source is another huge way that robotics has been accelerated. Like we've been talking about the RIOS community. Then another way to answer that is looking at actual robotics achievements. I'm a space geek, so I think any robot going in space is amazing and inspiring. So like from the space probes like Voyager to the recent Mars Perseverance rover and Ingenuity helicopter, which will be the first time we have powered flight on another planet. Those are super exciting. And then on the other end of the spectrum, I think having a vacuum robot in my house is very exciting too, because I hate to vacuum and now I don't have to anymore. So I appreciate those advancements as well. What do you think, Laura?
I really like your definition, Sarah, and the embodiment aspect. One of the popular definitions of robots that I'm familiar with is kind of the sense, plan, act aspect, which you kind of covered on as well. So like if you go into the vacuum example, a normal vacuum, you may have a sensor that tells you how dirty the floor is, but without a human to move that vacuum around, the vacuum can't really do anything by itself. It can't really plan, it can't really act. But when you have the robot vacuum, it has the ability to detect some amount of its environment, whether that's via a bump sensor or has some sort of laser some sort of distance sensor on it, it's able to use that and get an idea of what the room looks like and where it can plan how and where it's going to clean. In terms of the advancements, I agree about the advancements in compute, the advancements in connectivity and networking. If you look back like 10 years ago, I think, or is it even longer, with the PR2, they had all these big computes in it. The PR2 is one of the early mobile manipulator robots out of Willow Garage. And so they didn't really have as much ability to like offload different compute different places, but with the cloud and connectivity, you're able to really plan where you want to do your different compute aspects, what needs to happen quicker, what can happen slower, can be offloaded elsewhere. I think there's also been a lot of advancements in different sensing technology. Really popular sensor is like the RealSense cameras. They've gotten small and cheap. So a lot of robots use those from Intel. There's also LiDARs are now coming down in cost. Those are laser scanners that let you determine obstacles in your environment. So the advancements there allow robots to gain more capability.
And thank you for sharing, answering the question from various different angles. And when I was doing my research for this session, I realized that I haven't come across a more interdisciplinary field than this one. Many fields tout to be interdisciplinary, but you name it, everything is involved here. And I think that's where my next question is going for, because most of the people who have signed up for this session and in general may have a computer science background. And there is a perception there that robotics is more for electrical engineers or mechanical engineers, that it is more hardware focused. And there may be an element of software, but it's not as focused, or there are not many opportunities as far as computer science background or software engineering is concerned. What will be your response to that? Okay, Laura?
So I think there's the aspect, there's a lot of software required for a robot. There's the more traditional side of, like, depending what your robot does, there's navigation or motion planning, mapping, that type of stuff. There's the machine learning, artificial intelligence, but there's also a lot that can happen kind of behind the scenes, especially with some of the more, as the popularity of artificial intelligence paired with robots grows, you need databases on the back end, there's cloud computing. There's a lot of opportunity to use different areas of computer science with robotics. And if you think of it, a lot of times when you're doing your mechanical or electrical design, you'll work on it for a certain amount of time, but you aren't constantly iterating on that. While for software, you have the ability to constantly iterate and provide improvements that are cheaper and quicker to do than if you were to do a mechanical or electrical adjustment. There's aspects of, what did your customer buy? Did they buy a robot? Are they renting the robot from you? So software allows a lot more updates to be applied. And so there's always, I think that the industry is always going to have need of people with computer science background to get those features implemented.
Yeah, I totally agree. My experience, I do have a background in electrical engineering, but I have not been able to avoid writing software in my entire career. Like, programming is such a huge part of anything you want to do. So even if there are any EEs out there watching, pay attention in your computer science classes, because you will definitely need this no matter what you think. I guess seriously, there are some jobs in robotics which don't require writing software, but in my experience, it feels like the majority of jobs are more on the software side. And like Laura was saying, the way that I got into robotics was on that localization, mapping, planning, autonomy side of programming robots. And And like she was alluding to, the fact that we can distribute computation across robots and between robots and the cloud, that's an opportunity to bring in, distributed systems, that part of computer science, which was relatively new to me. Yeah, and then Laura also already mentioned, I think she started in embedded systems, which is a big area if you're interested in that, real-time systems.
Cool. Thank you for sharing that. And I'll build up on that question. But for our audience, if you have any questions for our panelists, feel free to write them in the Q&A widget and hit submit. We'll certainly take them towards the end of the session. So building on the previous question, let's say someone graduated with a computer science degree, or maybe they're in the final year, and they had not considered robotics as an option for them. So they have not taken many electrical engineering or mechanical engineering side of courses, but they do want to be more employable in that they have developed interest in robotics. So what resources would you recommend for someone with a, let's say, undergraduate computer science degree to become more marketable in the robotics industry? Sarah?
So I would say if you want to learn fundamentals, I would suggest looking for some courses. Like there's some pretty good courses on Coursera for robotics specializations that teach you the fundamental concepts, which are pretty helpful. But really the best way practically, I think, is to start getting hands-on experience building things yourself. And for that, I think the open source community with RIOS is really helpful. There's a lot of tutorials getting started, how to build your own system. Like look at Turtlebot, for example, the Turtlebot simulation. Even if you want to buy a Turtlebot, it's fairly affordable. You can maybe go in on it with your friends. Here's where I can do my shameless plug for Unity. Visit the Unity Robotics Hub for free open source tutorials that help you get started using RIOS in Unity, using Unity for simulation. But I think if you really want to make a good impression or show that you have experience, I think building your own projects and putting it on GitHub so people can see your code is probably a good start.
Yeah, I think, definitely RIOS is a great, as Sarah mentioned, RIOS is a great open source project to get involved with. In addition to what Sarah mentioned, I'm involved with a group called Women in Robotics, and we are a nonprofit professional network for women and non-binary folks that are either working in robotics or interested in getting into robotics. So it's a good resource. We host different events. We have different local and global chapters. There's the ability to network. We post different job openings. We'll share different workshops we hear of. It's a kind of another way to start learning and get familiar with what's going on in the industry. Another good kind of resource that I've followed over the years is IEEE Spectrum's robotics blog. So they'll post what some of the more recent updates are and what research is going on. There's a lot of other robotics industry focused news sources that you can go and look up. But yeah, there's definitely a lot of opportunities to get involved. And I think the aspect of getting your hands kind of dirty with a project is definitely a good way to approach it. There's definitely a lot of tutorials out there that you can find on Google.
For
one more thing that I would add.
Go ahead.
Sorry. One more thing that I would add is if you're currently working at a company, there's so many companies that are dipping their toes in the robotics field. Like maybe they have one side project or a research project. If they give you the opportunity to help out or maybe work on that project, snatch it up. Like, don't worry that you don't already have experience in robotics, because you have a skill set that would be valuable to them. Trust me. Use it, be selfish, and take that opportunity to learn more if it's given to you.
Absolutely. And that's a great advice no matter which field you are in. If you have an opportunity, don't wait for the feeling to sink in that I can do it. Just jump onto that. You will be able to do it. You are more ready than you are. Laura, about the Women in Robotics group, is there a website or a LinkedIn group? If people are interested in getting more information, where should they go?
Yes, I believe the website is just womeninrobotics.org. And that should have more information there. We have a Slack community that you should be able to sign up via that website, as well as like a newsletter to learn more about events and different upcoming things.
Thank you for sharing that. I'm sure a lot of people in our audience will find that useful. Talking a little bit more on careers, but now broadening our umbrella to any technical field, computer science, mechanical, electrical, any other. What would you think are some of the most in-demand careers in robotics, maybe for the next 5 years? Whoever,
I guess
I take that.
I can start. Yeah. I think there's definitely, right now, definitely machine learning, artificial intelligence, computer vision are very popular kind of subfield of robotics. There's definitely a lot of research and work going on there. Tech industry in general, people with strong machine learning skills is a very hireable skill right now, very much in demand. And a lot of companies are looking at how do we leverage these technologies to make robots more adaptable? How can they learn from their environment? So that's an area that's definitely hot right now, and I think will continue to be hot for at least the next couple of years, if not longer.
I was going to say the exact same thing. Definitely, like, the whole AI and machine learning is the hottest job across many industries, but including robotics. And there's kind of a shift from the classical robotics methods to learning-based methods, which makes sense because we want robots to be more autonomous and to be able to adapt to more situations. But if you have that skill set, it's fairly easy to find a job in robotics, I would say.
Thank you for sharing that. And talking about jobs, what does your day-to-day look like? How much of it is like sitting on the computer versus maybe working directly with machines?
So I am a manager now, which means I don't get to interact as much with the machines as I used to. So my job as a manager is yes, mostly behind a computer and in meetings, but a lot of it is involved in planning. So what are our teams and our products goals for the year? What are our goals for the quarter? And then I work with the developers on my team to plan each sprint. So what is everyone going to work on towards those goals that we've defined? Also, as a manager, I'm responsible for helping grow the careers of the people on my team. So what that looks like is making sure they have work that is aligned with their skills and interests and also helps them stretch into the next role. I get them feedback where it's needed. I make sure they're unblocked and have all the resources they need to learn. And I also help with the rewards cycle every year to make sure they're getting compensated fairly, help them go through the promotion cycle. So that's sort of the people management side of things. I also work a lot with customers, and actually during COVID, it's been in a way kind of beneficial that if you want to talk to a customer, you just get in a Zoom call, and everyone is really accustomed to that. I'm kind of curious to see how that will change after COVID. But anyway, so I talk to a lot of current customers who are using our product to get feedback about what's working well and what's not. And then I use that feedback to help inform our plans, our product plans. I also talk to a lot of potential customers who aren't using Unity yet to learn about what their use cases are and if they're not ready to adopt Unity, why, and what can we do to make our product better to make them more interested in adopting it. Yeah.
Very cool. Laura?
For myself, there's some amount of variation. So being a software engineer, there's a lot of aspect around, there is a lot of being on the computer, especially with COVID. Before COVID, it may be that I was more co-located with where a robot was. But during this time frame, there's actually a lot that can be done remotely, assuming you got all your network configuration set up properly. So depending on the day of the week, some days we try to kind of block off having no meetings. Other days, there's normally some amount of meetings in the morning to kind of sync up on different projects or do meetings to collect different requirements. I typically will be checking email and Slack, getting caught up on that in the morning, as well as planning my tasks for the day. There's some amount of doing code reviews, following up on anything that's open, getting those done. Some days I may be working on development, so it may mainly be coding in my editor. Other days it may be testing, and maybe that's in simulation, or maybe I go into the office so that I can actually be where the robot is and observe with my own eyes what's happening and debugging that. So yeah, there's some amount of variation depending what my specific task is for that day.
Yeah. Very cool. And debugging reminds me, I think we're having that discussion that when usually for computer scientists, we all know about the divide by zero error. A console will crash or the window will crash, but for robotics, that was really interesting for me to think that if we have an error like that in a robotics code, the robot might just shoot straight towards the roof and just crash or something. So it was interesting for me to visualize how divide by zero can actually manifest itself. And more on that, Laura. So how would you say the job of a robotics software engineer is different or not than maybe a software engineer that works on a website or works on the back end?
Yeah, so I think where they're similar is kind of the core of it is you want to write efficient, maintainable code. So you still need that core programming fundamentals and knowing kind of how to architect things to make it work well. Where it varies is robotics tends to have, at least in my view, a lot more complexity involved with it because you also have the mechanical and the electrical. So debugging is there's a whole different approach you have to take to debugging. The reason something in the system might not be working, it could be your code. It could be that sensor's not plugged in. It could be that sensor's not configured correctly. So there's a new approach you have to kind of take to make that more efficient, to kind of check off, okay, how do I know that this piece is working and I'm getting the information I need to into my code? So that's kind of one of the aspects that is kind of different from more of a web or a cloud-based thing. Is there's a lot more moving parts involved that you need to understand what they are and how they can affect what you're working on. So there's a lot more system view you have to take of things. And yeah, having something work in the real world, there's additional considerations. So obviously you need to make certain what you're writing is safe. How do you maintain safety of the system? There's different sensors or whatnot you can use to kind of incorporate that, but there's the potential impact is different from I pushed a new code release to something in the cloud versus I pushed the new code release to a robot that is around other humans. There's different things you have to consider and different steps you need to take to ensure that you did that well.
Thank you for sharing that perspective. That was very helpful. I have had experience being a software engineer for Amazon, but it's good to see the similarities and differences with that being in robotics. We already see a couple of questions coming in. Please feel free to write them in the Q&A widget and keep sending them. We will take them towards the end of the session. Sarah, a question for you from your experience. So you have a PhD and you're working in the industry. I'm in the same boat. But some people have the view that, okay, people who go for graduate school or especially PhDs, they are probably targeting a career in academia, like professorship, research labs, and all that good stuff. And maybe it's not required or suited for tech industry. Maybe it's like overqualifying yourself. I'm just playing the devil's advocate here. So what will your thoughts be that having that PhD degree and experience, how has that affected your career in technology? And now that you are a manager, how have you seen it affecting the careers of maybe those that you possibly manage?
That's a really good question. So I think it really depends on what you want to do with your degree as to whether it makes sense to get a PhD or not. And I would always tell people that if your goal is to make more money, then that's not a good reason to get a PhD, because you don't really make more money. In fact, like the 6 years or so that you're in school, you're losing a lot of money compared to what you would be making if you were working right away. And, you know, in tech is a very high paying field, so you can get paid very well, whether you have a PhD or not. What I have seen, I don't regret doing a PhD. I really enjoyed it. Like, I enjoy learning, like I said. And I think even though I'm not really using the actual knowledge that I acquired during my PhD very much on a day-to-day basis, as in like the facts, the data that I learned. The thing that was really valuable about going through a PhD program for me is it taught me how to have more structured thinking and how to take a really big, ambiguous problem and break it up into smaller pieces where you can apply the scientific method to each one of these little pieces. So I also learned, you know, how to find and process information myself, how to read papers, how to ask people when I need help, who to go to for help, basically learning to learn. And I also learned how to manage a project over a very long time scale where it's like, I'm the only one who cares about this, really. I don't have a boss who's pressuring me to like have these deliverables every week. I have to be very self-motivated. And that kind of teaches you to be more independent, I think. And so what I've seen with people that I've managed, it's not really about skills. Like, people coming out of undergrad have the skills, the basic skills they need to do the job, but it's more like those who have more graduate education, especially PhDs, tend to be able to work more independently sooner in their career than those who don't. And they tend to be have more perseverance. Like they'll take more time to figure out a very thorough solution to a problem before declaring success or before declaring they have to give up.
Yeah. Thank you for sharing that. And I couldn't agree more with you. That's what I say when people ask me about that. You have a PhD and now I'm working in the industry. Is that I did PhD because it was fun. I mean, I know people think it's torture, but for me, it was just fun. And also I wanted to call a doctor. My elder sister is a medical doctor, so I just challenged her with my PhD doctorate. So a bit of siblings rivalry was at play there. What will be a myth or maybe a distorted reality about the field of robotics that when you hear, you want to go like, oh God, not again? And what might you say to dispel that myth? Any interesting things that you might have heard?
I think one of the things is like, oh, Rosie the robot from the Jetsons, if you're familiar, this robot that could kind of do everything in the house. Oh, we're close to that. And it's like, no, we're not that. Like, there's this aspect in robotics, especially out of some of the academic labs, where they can put together a really great video of a really capable robot. And you're like, oh, well, look, it exists. Why can't it do X, Y, and Z? Well, there's a whole lot of extra complexities of environments, and you don't know how structured that lab environment may be. You don't know how many takes it took to get that video that got posted to YouTube. That could be like the 5th take. And this is something with like Boston Dynamics. You don't know how long it took them to program the robots to do that dance sequence. Like, was that a minimal amount of work, or were they working on that for years, building their software stack up to that capability that allowed them to do that? So I think you kind of have to be aware that there's a lot of factors that go into robotics, especially if you want something reliable that you aren't going to get frustrated with. If you look at some of the early robot vacuum cleaners, they kind of would just drive until they hit something, turn, and drive a different direction. They didn't really have too much planning on how they were going to clean the space. So I think we have to kind of be aware of our expectations of what we think these robots can do. And it's also on the engineers and the designers to keep that in mind and correctly communicate what is possible and what is not.
And that goes back to the question about careers in robotics. This is why there's so many opportunities, especially for people studying AI and machine learning, because all of these are not solved problems by any stretch of the imagination. And it's a big difference between saying something works like 99% of the time versus it works all the time and I'm not going to be irritated, because 1% is like a lot of failures.
And I don't think many are actually at 99% either. I think they're maybe 80% if you're lucky.
Yeah.
So what would you say is possible with the robots that we have today? What can they do currently? Not like 5 years or 10 years out, but what can they do? What are the capabilities that they are able to perform today?
I think some of it depends on what environment you're in. Like, if something is a lot more structured, you can program a lot the robot to do very specific tasks. I mean, if you think of kind of the traditional manufacturing with the automobile factory lines, like they very much know that at this point, this item will be here, so the robot can move to this hard-coded point, pick it up, move it over here. So there's some things where if it's not super dynamic, if you need something that's just like repeatable, you need the strength of a robot, it's very structured. I think that's something that they can do very well right now. But there's definitely a lot of work being done to be able to handle less structured environments. And this is kind of where the ML and the AI come in, of how do you detect exactly where that item is you need to pick up, and then get the motion planning to pick that item up, move it over to your other goal spot. There's definitely, I think, going to be a lot of advancements in the next couple of years and exciting products coming out.
Yeah, I think structure really is the key, because if you know the structure of the environment where it's working, then you can build in more assumptions to make the solution simpler. So like another example is autonomous driving on the freeway is like fairly simple because it's basically lane following. So you can assume that there's a road with lines, and that is a really helpful assumption to have. Imagine if you had to drive on a road autonomously and there's no lines. That's going to make the problem a lot harder. And even when you think about like what computer vision techniques can I use, for example, let's say I want to calculate depth from stereo cameras. So I need multiple features in my field of view in order to calculate depth. If I'm in a room with just white walls, with no structure, no like visual structure, visual texture, then those algorithms are going to break down as well. So like finding the algorithms that work where you don't know what the structure is going to be are really, really hard.
Thank you for sharing that. It's very important that we manage our expectations well, because there is so much hype around the field and what automation can do. And talking about what automation can do, of course, there are very strong opinions and emotions on the other side as well, that robotics or robots and automation may leave a lot of people out of job and poor. What will be your response to that?
So I think it's actually a very fair criticism. And I think that we, as people who are building these technologies, have a responsibility to make intentional decisions about what we're building and what that looks like. Because I think we're in an interesting time where the economy is shifting from like an extractive economy to manufacturing to knowledge-based, and within the span of a single person's life. And so we have a situation where people have been laid off from the industry that they were trained in. And then at the same time, we have a labor shortage in these new industries. So we do need to put thought into how we can reskill or upskill these workers so that they aren't left unemployed. Like, automation in theory should not be widening the gap between rich and poor. But we have to, be intentional about that. And so one thing that I think has been encouraging to me is that in the robotics industry, I've seen more of a focus on improving ease of use of robots. So historically, it's very, very hard to program a robot, to learn how to use it in an advanced manufacturing situation. And so there are companies who are actually focusing more on the software. And here's again another opportunity for software developers to have a big impact in making the user interface simpler and more intuitive, so that we can train a whole new workforce. So like, you shouldn't need to have a PhD in robotics to work in a manufacturing environment and learn how to use a robot.
Yeah, I agree with what Sarah was saying. I was reading a report that estimated like 80-ish million jobs could be removed due to automation. But in the same report, they predicted approximately 90 million jobs would be created due to new roles in automation. So there is definitely that aspect of, well, the people that lost their jobs, how do we reskill them to the new openings? And it's not something that you can say, oh, you just have to go and get a 4-year degree. Like, you have to be a lot more thoughtful of that and figure out what different roles are available, what different skills are needed, how do you do it, how do you simplify it? There's different like technician roles, so like being able to repair the robots, like there's a certain amount of maintenance that needs to be done. So there's a lot of opportunities that will open up as more companies adopt more robotic automation. But it's definitely something that, as developers, we need to be aware of and consider, how do we make this most equitable? What ways can we program this to create jobs that are fulfilling for people and enjoyable, and challenge them in a way that maybe working on a factory line previously didn't? So I think there's a lot of opportunity there to kind of define what the future of work is.
Yeah, I completely agree with that. There is a lot of opportunity on defining how the future of work will evolve. And of course, it involves discussions about all the new and emerging fields that are there. Taking a couple of audience questions, I think that might be best answered by Laura. So, is the interview process for a software engineer for a robotics job different than the interview process for a software engineer for any other type of position?
It will vary a little bit depending on the company. Overall, there traditionally is still like a technical aspect, and there can be still coding challenge, like whiteboard challenge type questions for a lot of robotics companies. Where it kind of will vary is depending on the specific role, if it's like, oh, you're a ROS developer, there will be some questions more related to around like how to use the ROS framework, how would you write a publisher or subscriber. So it may be a little bit more focused towards knowledge specific to robotics, but it will kind of vary depending on the role, because some roles may be doing more like higher level machine learning algorithms. And in that case, it might not be very different if you were interviewing for a machine learning role at Google. They may be fairly similar interview processes. But if you were like going to be doing like embedded programming for a robot, it could be like lower level, like C programming questions, or design a system, like what sensors would you choose to incorporate in this robot. So there's an aspect of, there'll be some system design questions still, there'll be some amount of technical question and answers, as well as probably some amount of coding, but it does vary a little bit company to company in terms of how they've defined their interview process.
Yeah. Cool. Another question is that our national average of women in technology in general is between 21 and 23%. That's the share that women have in various technology fields. Would you say it's the same in robotics or different? And it's, of course, more anecdotal. It's not like it has to be based on research or anything. What have you observed?
I mean, for me, it's varied depending which company I've been at. I've been on companies where like there was like 5 other women engineers on a team of like 15. So, but I've also been on teams where out of like 10, I'm the only woman engineer. So it's hard to know exactly for robotics. I want to say it's at least probably 10%, if not like 15 towards 20. I've seen some companies that are very intentional about how they hire and creating cultures of diversity and inclusion, and have women in leadership roles that will actually attract a lot more women and underrepresented groups in technology to go join that company, because they go and look at it and be like, oh, I'm not going to be the only one there. I'm not going to be the one token person. And so there are some companies that are doing it really well, so they have a reasonable amount of diversity, and others who aren't. So it's hard to kind of get a industry-wide feeling because there's so much variation.
Any insights from you, Sarah?
Yeah, I don't know the number either. My sense is that it's lower than the 20 whatever percent figure. And yeah, it depends on which company you're talking about, but I would say my experience is in most calls and meetings that I'm on, I am the only woman still. So I think we have a lot of work to do.
Yeah, we do have a lot of work to do. And as we continue taking questions, a request to our audience, there's a brief feedback form for this session, and it is brief because I designed it. It will take you not more than 2 minutes. If you can please go to that link and share your feedback and suggestions for future sessions, that will be really, really helpful to us. Coming back to our panelists. So how do you see the field of robotics evolving in the next 10, 15 years, especially now that we have seen COVID? Any significant changes because of that?
So related to COVID, and from my perspective, working in Unity simulation, we have seen a lot more customers over the last year rely on simulation more for developing, because a lot of people can't go into the lab like they used to. They can't work with the physical robots, and so they are using simulation more. And I really hope, obviously, that continues. Another thing that I was reading about recently with regards to COVID is how the global pandemic really revealed a lot of problems with our global supply chains and manufacturing. Like everything just was grinded to a halt. When people couldn't go into the factories anymore, nothing got made. And so some people are saying this is an opportunity to add more robots and automation to prevent things like this from happening. I've also read some interesting ideas about how maybe it doesn't make so much sense. What we used to do is mine materials in one country and ship them on a barge to another country where they get made into some parts, and then those get shipped to another country where they get assembled and then shipped to another country where they get distributed. And so when you have a global pandemic, all of that breaks down as well. So it might make sense to actually move the manufacturing back to the country where things are going to be sold. And to do that, that would require more robots and automation, I think. What do you think, Laura?
Yeah, I mean, I think what you said, there's definitely, those are going to come into play. I think, yeah, robots do allow for more social distancing within factory or logistics types environments. So I think there will be some increase in adoption due to COVID as employers are looking to keep their workforces safe. They will look at what they can automate. There's aspects of, if you put in robots to do some of the monotonous tasks, that you could have maybe where you used to have 3 people side by side, you're able to have those people spread out more and go bring the materials to the robots versus having to stand in one spot. So they'll be more maintaining and running the machines, getting them operating versus maybe what they were doing before. I also think there's, in the industry, there's a new kind of model that's called robots as a service, where basically the company building the robot owns it, but will place it at a customer location to do the job and charge them a rate either per pick or per hour, per day. There'll be some sort of rate cost. And I think that's kind of going to be popular because there's CapEx, which is capital expense versus operating cost for some of these manufacturing type places. And so depending on their individual setup, they might not have the ability to spend how many tens of thousands of dollars on their own robot. But if it's something that somebody else is owning it and they're paying for the amount they use it, it's a lot more interesting and easier for them to sell internally in their company as a way to move forward.
Great perspectives. Very cool. So I don't think there are any other questions at the moment. Any final thoughts on the topic that you may want to share with our audience, or any advice for them?
Robotics, I find to be a fun and challenging field. There's a lot of interesting work that's happening in it. So if you are looking for a career change or early in your career and trying to decide what to do, I would definitely try out some robotics projects, maybe learn a little bit about RIOS and see if it's something that you're interested in pursuing more.
I agree. I would add that I got into robotics not because I was very passionate about the end goal of having a robot that does something, but more because I find the problems in robotics to be so intellectually challenging and interesting, and it touches so many different areas of research like we talked about today. There's just so many cool problems to work on. I don't think I would ever get bored in this field. So I agree 100%. It's a really fun job to have.
Wise words. I don't think anyone will get bored in that field. I agree. Thank you so much, Laura, Sarah, for being here with us. Thank you so much, audience, for spending your last hour with us. This session will be available on demand in a couple of hours and then also be posted on YouTube in 3 to 4 weeks' time. So please do share your feedback with me, with us. Let me know any topics that you might want to have a discussion on in the future, and your suggestions guide my decisions. So please let me know. Thank you, everyone. Have a good day.
Thank you.
Thank you.